Hello everyone, my name is Sinia and this is my friend Jay and Preeti Jayabardhan. We are from Mount Zion Silver Jubilee School, Tirupattur, Tamil Nadu. Today we will be presenting our project, the autonomous drone for disaster management.
This project falls under the category of a novel solution to a problem. We aim to tackle challenges faced during disaster management using innovative drone technology.
Natural disasters require swift responses to minimize damage and save lives. Traditional methods often struggle with coverage and communication. Our project develops an autonomous drone system to enhance these capabilities.
Explore key principles such as aerodynamics for stable flight, artificial intelligence for human detection, communication protocols using Mavlink, and the integration of hardware and software systems.
We utilize several materials for our project. For hardware, we used a Raspberry Pi 4, a Google Coral USB accelerator, and a drone equipped with a Pixar controller, GPS, and a camera. On the software side, we developed the app using Flutter, employed DroneKit Python for communication, and integrated AI libraries for human detection and image processing. Finally, we assembled and programmed the components using tools such as soldering iron, a multimeter, and a computer.
To start our project, we laid out a clear plan. First, we defined our objectives by identifying specific use cases, such as aid delivery and search and rescue missions. Next, we carefully selected the components, ensuring we had the right hardware for optimal performance. Finally, we designed a user-friendly app that makes control and monitoring easy for users.
Next, we moved on to the integration and development phase. First, we assembled the drone by integrating all the components into its frame. After that, we installed the necessary firmware on the flight controller to ensure it was ready for operation. Finally, we developed and optimized an AI model for real-time human detection, which greatly enhanced the drone's operational capabilities.
Lastly, we focused on software development. We began by building the user interface for our Windows application, making it easy for users to interact with the drone. Then we implemented communication using DroneKit Python to ensure reliable data transfer between the drone and the control app. Finally, we set up real-time monitoring by incorporating Firebase and WebSocket, allowing for seamless updates during missions.
In conclusion, we assessed our drone success in disaster response and discussed future applications in military and environmental fields. Here are some of the references we used.